bring in a high-profile outside speaker, particularly aimed at the undergraduates and getting them interested in the wonderful things that happen in physics. And it's a lecture named after Robert Resnick, who is a famous faculty member from Rensselaer. Unfortunately died about 10 years ago. But some of his family are here. I say hello to his family up here in the front row. Thanks for coming out. And one of the interesting things that I was just told today is that Bob Resnick was actually our speaker's father's cousin. So he's actually in the family category too, as we just found out. So first I wanted to say something about Bob Resnick, and then I will introduce our speaker. Bob Resnick, so I usually don't introduce the speakers for a colloquia, but I'm often brought out for the Resnick lecture because Bob Resnick was actually my academic advisor when I was a student at Rensselaer many years ago. And he was, in those days, faculty were the people who they did recitation sections. I guess we have faculty that do the labs. That's a different way, but he was my recitation instructor for Physics 1 and Physics 2. And when I got through with Physics 1 and Physics 2, I said, well, maybe I want to be a physics major. So I went to him and he said, well, yeah, I think we could let you into the department. And so he was one of my mentors as an undergraduate student. And, you know, I actually remember when I got married some years later, after I was a graduate student, I got married in Saratoga. He came, and also my undergraduate research advisor came to my wedding, and all of my friends who came to the wedding, and all my husband's friends were really excited to meet Robert Resnick, you know. They wanted to know which one is he, because everyone used Bob Resnick's textbooks. He was extremely famous for writing his textbook. I mean, how many people here have used a physics textbook written by Robert Resnick? You can see it's going to be anyone who's older than 25, I'd say, and maybe a bunch that are not at 25. There are many, many decades where his textbook it was great. I had a recitation instructor who wrote the textbook. But yeah, everyone everywhere who was trained in physics was trained with his books. As I said, it's more than 10 million students. And so we honor his contribution to Rensselaer and his contribution to physics and physics education with this lecture. Which takes us to our speaker today. Our speaker today is Michael Barnett. Funny fact, I used to have an office right down the hall from him at Lawrence Berkeley National Laboratory when I was a graduate student, so I'm feeling like the world is very small today. Michael Barnett is a theoretical physicist. He got his PhD at the University of Chicago. I won't tell you what year. And then he did postdocs at UC Irvine, Harvard, SLAC. He was at Santa Barbara for a little bit, and now he has a permanent position for quite a while at Lawrence Berkeley National Laboratory. If you ask him, and I did this morning, what he's most proud of having discovered, and he says it's to have found that the standard model is actually the correct model for particle physics. So that's a pretty big accomplishment, I would say. But he's also done work in quantum chromodynamics, supersymmetry, which I guess didn't work out so well in the end. It's a problem with being a theorist, is you can do everything absolutely right and it still doesn't work out. Top quark in the Higgs boson. He's a fellow of the American Physical Society and the American Association for the Advancement of Science, and was awarded the Dwight Nicholson Medal for outreach, so he's had quite a distinguished career. In fact, he's been credited by Sheldon Glashow, whoever that is, famous physicist, as the first person to suggest there should be 6 quarks, which is, that part turned out to be right. He was for 25 years the head of the International Particle Data Group, And this is a collaboration of 240 physicists who all have to get along from 173 countries and labs all over the world. And they put out a really important book, which is the book of all the things that we know about all the particles, and it comes out, yearly, right? It comes out every year, or 2 years, every 2 years, with the update on all this. And I told him when I saw him this morning, I said, I have one of those books in my desk. And I actually wasn't sure I did, but I looked through my desk and I did have one from 1992, because everyone carries one of these wherever they go, the particles in the particle data book. So it's where everyone goes to find out what the latest is on particles. So that's a really big deal. And he is now turned to doing more education and outreach. And education and outreach is the topic of his lecture today, where he's going to talk to you about work he's done on a Planetarium show, and I'm not sure what else is in the talk. But without further ado, I'd like to present Michael Barnett.
Well, thank you all for coming. It's a little unusual probably for a physics talk, because a lot of it's about the Planetarium show, not quite all of it. Some of it's just about dark matter. But anyhow, I appreciate you all coming. So just to get started. So she mentioned that 10 million students had used this book, and yes, I used it. And that's exactly the textbook I used in my first year in college. And as a physicist, by the way, this is Resnick and two authors of the book. And as a physicist and educator, I'm honored to speak at a lecture series named after him. So recently, the magazine Physics Today had this little commentary here saying that 2 papers appeared in 1974, so a long time ago. They changed the face of the universe. And one of those was in the US and the other was in Estonia. And what they note here in this Physics Today article is that various astronomical observations show that most of the universe's mass is hidden in invisible clouds around galaxies. And they say changing the human understanding of the fate of the cosmos. I'm not entirely sure that's completely accurate, but okay, that's what they said. And in any case, these papers propose the existence of what we now know as dark matter, although I don't think either paper actually used that expression. So the reason dark matter is important is that you're not made out of what most of the universe is made out of. Most of the universe is this dark matter, and about 85% in this pie chart. Actually, if you do mass and energy, then dark matter is 24%, but then our kind of stuff is, it says here, 4.6%. I'm not going to discuss dark energy, but what dark matter is some sort of matter. We don't know what. Again, I emphasize we don't know what it is, but we know that it exists, as I'll tell you in a moment. It does not emit, absorb, or reflect light, so it is actually invisible matter, not dark matter. And it plays a key role in the universe, including holding galaxies together, such as our own galaxy. So the question is, what evidence do we have that dark matter really exists? And the Planetarium show partly addresses that and more. So one of the first things, maybe the first thing, was this work by Vera Rubin, who noted that the outer regions of galaxies rotate, and you can look at the figure up there with the arrows, rotate faster than if there was only visible matter. So there must be some other additional mass exerting gravitational force. That's the only thing we know that it feels. That is done by dark matter. So again, this is Vera Rubin doing something. There's a second thing, is looking at the cosmic microwave background. And you look at the afterglow of the Big Bang, and that provides you a snapshot of the early universe. And if you look at the temperature fluctuations, as in this figure, that matches models that include dark matter and doesn't match things that don't. This is sort of I always like this. It's the large-scale structure of the universe, and it's this figure. And I think in very small print it tells you what that distance is. It says, I can't read it anyhow. And the point is that the distribution of galaxies, I mean, why isn't it just all homogeneous? And the answer is that there's dark matter. And the dark matter is believed to form these structures, and from which these structures form galaxies and then clusters of galaxies. So the point is that in galaxies there are stars and planets, you and me, and without dark matter there isn't any you and me. So it is crucial to our own existence. So gravitational lens is another one. If you look at that figure down there, it shows some big gravitational object, star or whatever, and you have an observer on the right and the source is on the left. And what happens is that you get this lensing effect, and if you do that, the lensing effects are stronger than being accounted by the visible matter alone. And so again, you think there must be dark matter. And then this one's in some sense the most direct and obvious one. There were two galaxies that came along and collided. And galaxies have a lot of dark matter around them, and they have something else which is gas, most of it, and they pass through each other. But when they passed through each other, the gas started interacting with itself. Two atoms crash in, slow down. The dark matter went right on through, and so when you were done, the dark matter was out there, and the gas had only gotten this far, and they were both heading out that way. And you actually can only see the dark matter through gravitational lensing, but that's the story here. So what happened, the separation of dark matter from the hot gas in the colliding galaxy clusters showed that dark matter does not interact with normal matter except through gravity. And so we have this other evidence. The problem is we have no idea what dark matter is. We've done a lot of attempts at the Large Hadron Collider and deep underground experiments and various other things, and it remains one of the greatest mysteries in science. Down below I says perhaps the greatest mystery of modern physics. I don't know, you might argue with that, but anyhow, it's what I would say. So we have ongoing and future experiments desperately trying to find, directly detect dark matter particles and identify the nature. Now there is a possibility, I don't really believe that dark matter is not explained by particles. I can't tell you that isn't possible, but the general belief is that it is. The thing you need to understand about dark matter isn't just out there in some galaxy far away. It's all around us. It's in this room. You hold up your hand, and billions of dark matter particles are going to go through it in the next minute. But they don't touch you. They won't cause cancer because they don't interact with you. They're particles you can't see or feel, but it's everywhere. It's in this room. I mean, they can go through Earth. So, in general, maybe this is why you got into physics. There are mysteries, and trying to understand these mysteries is really exciting. And I think it's natural that we would want to share that excitement with others. So, what are the components of dark matter? It's a great mystery. It has been for 50 years now. So what happened was that three of us decided we wanted to make a planetarium show as our way of sharing the excitement. Those are the three. The important thing to realize, since you may not have any experience in anything like this or even making a film, is that none of us had any experience producing a show. We got a lot of other people involved, and none of them had any experience in making a planetarium show. It was a bit of a learning experience, and we had to feel our way along, and that's why it took 3 years. But we made a show that's been seen by approximately 2 million people in 840 planetariums in 77 countries and in 28 languages. This is the language I know about. Some countries, there's 77 countries showing, so I'm sure it's in other languages, but they just didn't tell me. we started this, we were thinking, okay, it'd be great if we could get into 30 or 60 planetariums, but instead we got into 840. So how did we do this? What we did was to try to find really outstanding people. So I went around and listened to a lot of documentaries, who the narrators were, and I decided on somebody I'll get to, who was an Academy Award-winning actress, to be the narrator. And then I was able to get a team at Skywalker Sound, which made Star Wars, etc. Also, who was an Academy Award-winning team. So actually, I spent 2 days, all day, at Skywalker Ranch, working with this team of 5 people. And we also found a Hollywood scriptwriter and producer who had done documentaries, not a planetarium show. And we have a director who was head of the media lab at CERN. And there was more. We had these experts from 7 different planetariums that we interacted with. We had 5 professional animators who had never done a planetarium show. They'd done things like normal flat screen. We had a camera person from the Adler Planetarium who filmed the scene. It's only about 5% of the whole show. The rest of it's, I'll tell you more. And lots of other people. When you look at credits in modern TV shows and movies, there's an endless array of credits in. Well, we have a lot of credits at the end too. I mean, some of the roles are small, some are big. So one of the things you make something for public, you got to really think about who is your audience. And in our case, we went at both students and the public. I need some water. And the thing about planetariums too is that they have a lot of school visits and of course students coming in with their parents, and that's about half their audiences. So it's a lot of people, a lot of young people, and we really hope to inspire them to either explore science as a career or just as a hobby, either way. Learn something about science, how it's done, etc. So why do we want to make a planetarium show? Well, it was, we've been doing other kinds of outreach, and this was something new and different, so okay. It's really dramatic because it's all around you. It's on the ceiling, it's behind you, it's on the sides. So I like to say it's more dramatic than an IMAX movie. And we thought about showing galaxies, since one of the things I'm going to tell you about was that there's spiral galaxies that are rotating fast, and there's not enough mass there for the gravity to hold it together, and it should just blow apart. Well, so we have a scene in the movie where a galaxy, we say, what happens if we took away the dark matter, and it blows apart and goes down the side of all the walls of the planetarium. So that was a great thing. And then we also showed the Large Hadron Collider, which is a ring which you could go around the whole room, the protons doing this. And then when we have collisions, they could happen up here, and then all the particles that are produced rain down the sides of the planetarium walls. But that was our ideas when we started. But as we did it, we realized there's more reasons, and we discovered that the hundreds of planetariums, as I said, now 840, had an interest in a dark matter show, which is not necessarily obvious. It's not directly what they normally do. The other thing, though, you see if most movies come to a theater, if you remember what a theater is, they show our show for months at a time, and actually sometimes years. I mean, when it gets beyond a year, they're showing it once a month or something, but they're still doing it. Which reminds me that there's a planetarium in Schenectady, not too far from here, and they have a show. I wrote this down somewhere. Come up with it eventually, later. I think it's on the 26th of October at 8 p.m. from memory. Except they're also serving alcohol, so you have to be 21 to go. But I think they'll be showing it again after that. So again, they show it for months at a time, if not longer. They have a perfect science-interested audience for us, students and the general public. And 110 million people a year watch Planetarium show. And I don't think any of this would have been possible if we made an ordinary film. I don't think, how we would have gotten it really seen that much. So this is something I want to tell you. It's a little story, I guess. There was a program 40-something years ago who had an actor, Don Novella, who played a character he called Father Guido Sarducci. And he had this thing where he said, I got this idea for a school I would start, something called the 5-Minute University. The idea is that in 5 minutes you can learn what the average college graduate remembers 5 years after he or she was out of school. And we have a show that's 27 minutes long, so we have the same problem. What is it that we can show that they would actually remember? It's not obvious, if I give them all kinds of physics stuff, most of it they won't remember. So what we thought about was we want to show them the excitement of exploring science. And I can tell you from my own experience, it can be really exciting, especially when they find something that you were hoping they would find, like the Higgs boson. It gives you a sense of the mystery around dark matter. We can't tell you what it is because we don't know. We can talk just generally how we explore the mysteries of science. We also show something about the tools of scientific exploration. We do that definitely. And again, as I just did to you a few moments ago, we show that dark matter is real, that it's everywhere. Now again, since it's 27 minutes, and that's typical of a planetarium show, that we wanted it not to exceed what planetariums were willing to show. Well, some of the highlights were that dark matter is created in the Big Bang. We have evidence, there's evidence for dark matter in galaxies, clusters of the galaxies, etc. We wanted to talk about this underground search for dark matter, and we wanted to talk about dark matter at the Large Hadron Collider. Making a show like this is complex, and it actually took us 3 years. I actually spent 3 more years trying to raise the money. This was like more than $1 million in costs. The show is 95% animation, but it's a very realistic animation. At times it looks like you're looking at the real things, but it isn't. Now these animators had a lot of experience with normal films, in a rectangular screen. But that's not what they're in planetariums. We have this spherical thing, so we had to train them on how to do this. Then we had to go to planetariums when they'd done some work and see if this really looked proper on a planetarium screen. So we were actually at 7 different planetariums at different times trying to see if what's going on. Now when you make a movie, what you do is you just post-its up on the wall, and like I'm showing here, which is for our show. But in fact, I went to Pixar Studios once, got a tour, and I saw something exactly like that. And I asked if I could take a picture, but of course this was a new forthcoming movie, so they would not let me take a picture of it. So this is a picture of our show, but this allows you to say, no, maybe we should discuss that after we discuss this, and move it around. And then you see things underneath where you say, yeah, but we should add to that this other stuff. And so this is a very effective way of figuring out. Now, you've already got a basic idea of what you're going to do in the show, but you have to figure out how you're going to do this in a movie. And it's different. So as I said, I know for one that Pixar Studios does this, and I presume others do too. But you want it to have a coherent thing. You don't want to, at one scene, assume something that you haven't talked about yet. So it's crucial to have something like this. So this was actually our animation team. We got them all they were all Spanish as it turns out, and we got them an office at the University of Valencia in Spain, and so that's where they worked from for a considerably long period. I don't know exactly, but it's on the order of 2 years. It's a lot of work, training and so on. And then I was succeeded in getting Tilda Swinton to do the English narration. As I said, it's in 27 other languages, but Tilda Swinton has won Academy Awards, and up there is a list of some of the movies that you may know that she's done. But again, I decided I wanted her because of looking at other documentaries and thinking that she was the best narrator I could see in looking at things. So the question is, how do you get a famous movie star? And the answer is, it says what I already said. And what I did was to Google her agent and explained that this was an educational show and that we weren't making money. In fact, we charged zero for it. And so we got a really good deal. They charged us, she charged us very little. In fact, half of what she charged us went to her agent. And then the sound, again, I managed to find somebody there. I think that's on the next slide. But anyhow, I went to Skywalker Sound, spent two full days there with this Academy Award-winning team. And again, Skywalker Sound, which is at Skywalker Ranch, is made all these movies that I'm showing down there. I won't read them to you. But it ranges from Titanic to Star Wars. So, how do you get Skywalker Sound involved? Well, I found a friend who knew somebody who worked there, not an important person, but somebody who worked there, and that got me in. And again, I pushed this idea that this is a purely educational project, and we're not making money. When I say nonprofit, it's not really right. Nonprofits make money, they take in money. We took in zero, nothing ever. And okay, I think I've said the last paragraph there. And again, they charge us very little. I mean, it must be a tiny fraction of what they would normally charge somebody. Now, they wouldn't let me take pictures there, so this is a picture of Star Wars, but it's more or less the same room. So we had a screen like that up there. We had people working these boards, and then we were, see that one head there, that's sort of where, more or less where I was. And we would, go through it, and I think at one point I said, I think that sounds too high. And then this guy who was an Academy Award winner said, no, this is right. And I thought, okay, he won an Academy Award and I didn't, so I guess I'm going to believe him. So anyhow, the same room, but obviously not that topic. So we ended up in 840 planetariums in 77 countries and 6 continents. This is the list of languages. I do point out that what I'm calling a language, in some cases you look at the Spanish. We have a Mexican version, a Spanish version from Spain, and a version from Argentina. We didn't do this, it's what they wanted. And as I said before, I'm sure there are a lot more languages that they just didn't tell me about. And these are the languages actually we posted on our website so others could use it. But if people didn't want others to use it, they didn't tell me. And again, we distribute it for free. There's some examples of cities, some major cities as the first set. And then there's a second set of some other places ranging, to Nairobi and Cape Town and Easter Island, Kathmandu. So just everywhere. Even, I like to say, physics supersedes world conflicts, which is true in a lot of experiments. If you go back to the CERN lab, people from places that are in conflict are working together on an experiment, and somehow physics doesn't let that overcome us. And so, like I said, it's been showing in Ukraine for a very long time, although I'm not sure right now if it is still doing it. Some of the, at least one of the planetariums was actually in the war zone, so I don't know. U.S., China, and Russia, Iran, Israel, United Arab Republics, Qatar. So there were all these things which are kind of like amuses me. So, about 8 years ago, the amazing thing is I'm still getting requests for the show for new planetariums, but the premiere was about 8 years ago, and the premiere was, somewhat to our surprise, was in Vienna, in Germany. And it was at this Museum of Natural History, which is basically a palace. I'll show you the insides. And actually, this here with me is George Newman, the laureate. Speak behind me. Amazing place to be speaking in. This is more of what that hall looks like. And up there, so the salute Nobel Prize winner, Peter Higgs, Nobel Prize winner, and then people who run the planetarium, and the Natural History Museum. So it was kind of amazing to be there. And so we did that. We got a lot of good feedback. The director of the museum, not the Planetarium, but the whole museum, said that it was visually stunning and scientifically fascinating. And the Planetarium director said that people love the show. Everybody who's seen it tells me that it is the best show they have ever seen in the Planetarium yet. And they showed it, I don't know, like 6 years or something. They've recently stopped. And as I just told you, the premiere was attended by Peter Higgs, George Smoot, the Austrian Minister of Culture, and other such dignitaries. And then, of course, beyond just that one planetarium, things I like is that, for example, they told us that, the people who were extremely impressed with the show included their own Science Center staff, high school students, and university students. And then another director said, we just had a great experience with middle school boys, and why it was only boys, I guess it was at school, who were very engaged throughout the show. The visuals caused them to break out into cheers, and I had thoughtful questions afterwards. I've also given talks to audiences where middle school students asked me questions, including about dark energy. That wasn't in the show, so they started asking me about that. And now I'm going to show a trailer, and hopefully the sound level is not too loud, as it was earlier. This is not, is without the narrator except at the very end, because it's just a bunch of different clips of different scenes during the show. And the music is from the show. And
Phantom of the Universe, The Hunt for Dark Matter.
of course, if you see this in the Planetarium show, this is all out of context, so it makes a lot more sense in the context of the show. But that's gives you some feeling of the type of animation we have. And again, you would, in the show, you would see it with the narration, but it doesn't have it here. So apparently I talked faster than I expected to, so basically at the end, this was expensive, and we raised it from all kinds of places and agencies and this and that. NSF and DOE, particularly in the U.S., that the Atlas experiment, for example. My collaborators were at Michigan State University and the University of Texas, Arlington, and all these other places. And that is it. As I say, we give it to Planetarium for free. There's a website which is shown on there. And that's it. We take questions.
Hi, so I'm impressed. Did you say you made that for $1 million? Did you
We
say?
raised more than $1 million to make the movie.
Okay, but.
That's part of the reason we raised the money, and then we didn't have to charge for it because it was all fully
That's
paid for.
impressive that you could do all that for $1 million. That's really, you really did get a good deal with that.
Well, a lot of people gave us their services either for free or for much, much less than they would ordinarily do. I mean, Tilda Swinton and Skywalker Sound, I mean, it was a tiny, tiny fraction of what they would normally charge.
Mm-hmm.
But we pushed the idea that this was educational and we wouldn't make money on it.
Okay. And you take questions on dark matter or on planetarium show me.
Don't promise to have good answers.
Yeah. Yes, ask whatever you want. You've got someone who's been around quite a while.
Hi. You said dark matter you don't believe is anything but elementary particles.
Personal belief.
Sorry?
My personal belief, but
Yeah, I
there are
understand
people
this,
who make up
okay.
paper. The paper's been written with other ideas, but I don't think they explain everything that we've observed,
The other ideas.
the other ideas.
Could you expand on that? Like what's...
No, I haven't paid much attention to those papers, sorry.
Okay.
I mean, I think there may have been people who talked about things that happen to gravity under certain circumstances.
Sorry, I don't even...
At large
mean by
distances.
gravity, that's dead. No, like, I don't know, machos. The discussion came back to machos after LIGO and the possibility of primordial black holes, and that one saw that the macho searches in the 80s were actually not correct because the wavelength of the particle that you're looking for is of the size of the aperture that you're looking with, so it doesn't really matter. But from a particle, like how come you're so convinced that it's a particle?
Well, for a long time, we imagined particles that are, for example, produced by or part of supersymmetry, and these are very massive particles. The Large Hadron Collider has been running a long time without seeing them, to my disappointment. I sometimes say that nature wasn't as smart as me. And now what's more the fad, that was the fad, everybody believed in that at one point. Now the fad is more with what are called axions, or very light particles, extremely light particles, and I've heard, I don't know, 8 or 10 different versions of that, and that could be true. And then one of the big questions is, does this dark matter interact with itself? It doesn't interact with us, should we say. It may or may not interact with itself, and that would lead to different things that you can see astronomically, and people are looking for that. Another question? No, sorry, you provided the answer. That wasn't a question.
No, thank you very much.
What's the answer? Thank you. Okay.
Okay, so you have a
Can you lower
figure.
your mask for a second?
Say what?
Lower your mask so I can hear you.
Okay, that's good. So you had a number they gave us, or a rate at which dark matter particles would be passing through our bodies.
Billion to your
Right.
hand in a minute.
And we also know that neutrinos are passing
That's true
through
also.
our bodies. We also know something about the masses of the 3 maybe varieties of neutrinos and so
Correct.
forth. So there's a ratio between the masses of neutrinos and dark matter particles, apparently. What would that ratio be?
Well, again, originally we had this theory where they were very heavy, much heavier than neutrinos. And now they're talking about things that are not that different, so we say, from neutrino masses. But we don't know. And again, there's a variation of what masses it could be, so it could be lighter, it could be heavier.
Okay, so the rate you were giving would be relying on the assumption that they might be on the same scale as neutrinos.
They could be.
in terms of mass.
They don't have to be, though.
I have a question.
Trevor,
So we invited some high school students. I'm curious to see how many showed up. So some folks may be here. So I'm wondering, when you were younger, what inspired you to get into science and any particular study field you ended up studying?
my mother was a chemist, and at some point when I was 12 years old, she bought a book called Explaining the Atom. And up to that point, I was sort of thinking maybe I'd be an engineer when I grew up. At 12 years old, she read me this book, and as she described it, she read me the first third, I read her the second third, and I finished the book on my own, and I was a physicist from ever after. So parents can make a difference, and you think about people who come from families where parents aren't educated, and what a disadvantage they're at. And my father was a biologist, but still I had this family that assumed I would go to college and go to graduate school, and that's not true in many families, and that puts them at an enormous disadvantage. And I wish universities would pay more attention to that. They do. They pay some attention, but I think not nearly enough.
I have a follow-up question. So this probably inspired quite a few students to get into science. What do you think that we could do based on maybe your ideas to do something similar?
Yeah, I mean, a lot of things that are a lot simpler, don't cost so much. You can make a film. It's hard to figure out how you're going to get that distributed in a way that people would see it. You're not going to get into major theaters to make a film unless you do something really dramatic. And remember, this is 27 minutes long, followed by an endless list of credits. But there are other projects. We made some wall charts, made the book. Books still get read at a level, and you give public talks, go to schools, talk to the students, especially if you're not a white male, as role models inspire other people to follow them. And so I have given talks in schools, even elementary school. And you've got to think about your audience. I think a crucial thing in any of this is to really think about your audience. Because if you don't think about your audience, you may go over their head, or you may go under them, or whatever it is. You should understand your audience and what they might be wanting or expecting.
How was your view of what this was going to be evolved by the people who were actually in the performing arts?
Like the narrator and the sound
Yeah.
people and professional script writers and all that. Did it evolve? Well, I don't think it evolved tremendously. The script writer was very important. I wrote the first script, but I did that professional quality, so we would then hire this Hollywood scriptwriter, and she wrote it, and she actually, what she did, it's an interesting thing. She went around and talked to other people. She didn't just read my script. She went to talk to other people involved in the search for dark matter to learn more for herself so she could write the best possible script. And so a lot of credit for the success of the show goes to her because she was a professional. She'd done documentaries before. She hadn't done a Planetarium show, but she'd done documentaries, and she knew what she was doing, and she worked really hard. Although I think it was underpaid, because she didn't realize how long it would take her to do this. But, you should involve, projects I've done, I've always tried to involve high school teachers, people who know something more about students than I might know, and more than one. You need to because you get different opinions. So doing outreach is a tricky thing, and most people probably have never done it, or at least not done it really well. So you need to involve other people. And like I say, the scriptwriter for us was a really critical person. She was also the producer, by the way, and so she also did other things that really contributed to the success of the show. So, again, know your audience, involve other people, particular school teachers, always try to involve them, and maybe other teachers or other students. Know your audience and involve your audience.
I'm giving a presentation. Oh, sorry. I have a term paper in brain. Is it okay to ask questions specifically about my topic?
Why do you need my permission?
Okay, sorry.
I can hear the question.
So I'm doing a look into the cusp core problem. So where the predicted dark matter halos are cuspy in nature from n-body simulations, but our observations, we find them to look more like a core. And from my understanding, the waves either happens either we're observing them, like we're not understanding what we're observing correctly, and then it actually look like what we're expecting, that the cusp turns into a core, or that the lambda cold dark matter cosmology is wrong, and that it's not that the cold dark matter is interacting that way, but we don't have that kind of dark matter, or else we would be getting the density profiles that we see. So with respect to that problem, the cusp core problem being that we see a different halo density distribution than we actually expect. Do you have any thoughts on what's causing that?
I need you to answer that.
Okay.
The question is why is there, what causes
the
the,
density, why aren't the dark matter halos have the density that we expect from n-body simulations that we observe?
well, I thought you just answered that in your question, didn't you? You
Well,
get the three possibilities.
Well, like, which possibility do you agree with? Like,
Oh, I don't, nobody knows,
okay.
right? I mean, nobody knows, so.
That's what I would have said, so I'm glad she said it.
Yeah.
Okay.
No, I mean, sometimes I'll come up with, my feeling about something, but I have to have some reason to believe one way or another. In this case, nobody knows.
All right, I agree.
Thank you.
You said this film premiered 8 years ago?
Can you speak up more?
This film premiered 8 years ago, right?
When it premiered, yes.
Yes, sorry. In the past 8 years since this film was premiered, have there been any major sort of advancements in the Hunt for Dark Matter at all?
So that's an interesting question. We actually hoped they wouldn't find dark matter when we first did our show, although we weren't thinking about 8 years. We were hoping it, wouldn't discover dark matter for at least 2 years, because then our show would be completely out of date. But they haven't discovered it, so the show isn't out of date, and often 60 or 70 planetariums each year keep still requesting it after 8 years. But yeah, if it had been discovered, we would have to have done a revision or anything else related to that was important. But I look at the show now, and I don't know that we have anything that we want to change now, because unfortunately the progress has been slow. Physics can be that way. I mean, you can have periods of enormous excitement, and then you can have dull periods. When I was a graduate student, it was an incredibly dull period for physics, or particularly for particle physics. And then around 1974, it just took off with the discovery of the charmed quark, and it was just one thing after another for a long time. Right now, we're actually in a slow period in particle physics, partly because we can't figure out what dark matter is. If it's a particle, we don't have a clue really of its nature. While we do have some know what it isn't, we don't know what it is. Physics can be hard, and it can be exciting, and it can be, tremendously rewarding, or it can be slow. You've got to be prepared for that. I mean, there's always interesting things going on in physics. It's not When I say it's a slow, I just mean slow relative to what you would like, but there's always something exciting happening. Read Science Magazine or Physics Today.
Okay, are there any other questions? Oh, got it, got hand up. Go ahead.
Okay, somebody back there?
No, you, go ahead.
Oh, no, okay. Okay, what's so cold about cold dark matter? I mean, why do people call it cold?
It's because the particles are very heavy and moving more slowly than they do with the ultralight particles, which can move near the speed of light, and they're hot. I think that's the right answer. Right?
Is that about right? Okay.
All right.
I mean, cold, I don't know. I find the word cold a little funny. It means it's not relativistic.
Let's thank our speaker.